Now exercise numerical number 1, 3.1 I am discussing right now. Okay. The storage battery of car has an EMF of 12 volt. If the internal resistance of the battery is 0.4 ohm, what is the maximum current that can be drawn from the battery? Now you can understand it very easily. Okay, say for example, you have your battery which is having its electromotive force to be 12 volt. Okay, so here this is the battery of 12 volt, this is internal resistance of the battery, and this is the external resistance, some bulb, whatever, some device which is joined whose resistance is R, and this resistance is small r, and electromotive force is E. Now if current I is flowing, then according to Ohm's law we can write I is equal to voltage upon total resistance of the circuit. Total resistance is R plus R. Now maximum current is asked. So if this external resistance is 0, okay, if the external resistance is 0, then and then this I becomes maximum. So maximum current that can be drawn is equal to E upon R, and the value of E is given 12 volt. Value of internal resistance is given 0.4 ohm. So the current, that is maximum current, is 30 ampere. Okay, very easy. Now second numerical, a battery of 10 volt and internal resistance 3 ohm is connected to a resistor. If the current in the circuit is 0.5 ampere, what is the resistance of the resistor? What is the terminal voltage of the battery when the circuit is closed? Okay. Now this can also be calculated easily. You have, first of all, whenever this kind of sum comes, you just draw the rough circuit for the sake of understanding. Okay. Say this is external resistance which is joined, and this is the internal resistance of the cell. Okay, the value of R is 3 ohm. Okay, the electromotive force is 10 volt. Okay, and external resistance we want to calculate. Okay, the current flowing is also given. Okay, this current which is flowing here, I, is 0.5 ampere. Now it is very easy for you. According to Ohm's law, I is equal to total voltage which is applied, that is EMF, okay, upon the total resistance of the circuit. Okay, so now you can easily calculate this. Okay, value of I is given 0.5 is equal to E is given 10 upon R plus 3. Okay, so here 0.5 R is equal to, 0.5 R, we have to write plus, isn't it? Plus 0.5 into 3, that becomes 1.5 is equal to 10. Okay, so 8.5, you can write 0.5 R is equal to 8.5, because this 1.5 goes on the right hand side, 10 minus 1.5 will become 8.5. So resistance R will be equal to 8.5 divided by 0.5, so this becomes 17 ohm. Okay, now terminal voltage, as you know, V is equal to E minus IR. Okay, so electromotive force is given 10 minus I is given 0.5. Okay, and internal resistance is given 3 ohm. So 10 minus 1.5, so this becomes 8.5 volt. Okay. Now numerical number 3.3, three resistances are there of 1, 2, 3 ohm combined in series. What is the total resistance of the combination? As they are in series, addition only we have to carry out. So total resistance is the addition of all these three, that is equal to 6 ohm. Okay, so this is very easy to understand. If the combination is connected to a battery of 12 volt and negligible internal resistance, so internal resistance in this case is 0, potential drop across each resistor we want to find. Now see, this can also be calculated easily. There are three resistors first of all. Which are those resistors? 1, 2 and 3 ohm resistor. Okay, and the battery is connected, and the value of this voltage applied is 12 volt. Okay, so this is a battery of 12 volt and internal resistance is 0. This is of 1 ohm, this is of 2 ohm and this is of 3 ohm. So total resistance of the circuit is, say, R is equal to 6 ohm. This is very easy. R1 plus R2 plus R3, you can take 1 plus 2 plus 3 is 6 ohm. Now current flowing through the circuit can be found. Voltage, that is E, that is electromotive force upon resistance. Now see, electromotive force is 12 volt, resistance is 6 ohm, so you will have 2 ampere current passing through this circuit. So 2 ampere current is flowing. Now voltage across this first resistor. See these points, I give the name A, this is B, this is C, and this point is D. So voltage across AB, VAB is equal to, voltage is current multiplied by resistance. So current is 2 ampere and resistance between A and B. Try to understand resistance between A and B we have to take. Yeah. Resistance between A and B is how much? 1 ohm. So 1 we have to multiply, because V is equal to I, okay, I into R. So I is 2 ampere, resistance is 1 ohm. This becomes 2 volt. Similarly, you can write VBC. Okay, VBC can also be calculated. Okay, VBC, VBC, VBC. Then current is same, 2 ampere, because in series current is same, but resistance is 2 ohm. So instead of 1 we shall write 2 ohm. So this becomes 4 volt. Okay, now you can find voltage between CD, voltage between CD. Okay, so that can also be calculated easily. How will you calculate? That is easy, you can calculate on your own even. Whatever, VCD, VCD, then current is 2 ampere only, 2 multiplied by resistance between C and D. What is the resistance? 3 ohm. So 2 3s are 6 volt. So 6 volt will be the potential difference between C and D. Okay, so easy calculation. Now numerical number 3.43 resistors are in parallel, 2, 4 and 5 ohm. What is the total resistance? Again you can calculate easily. 1 upon R1 plus 1 upon R2 plus 1 upon R3 can be done. Okay, so 1 upon R is equal to 1 upon R1. R1 is say 2 ohm, plus 1 upon R2. R2 is say 4 ohm, plus 1 upon 5 ohm. Okay, if you simplify this, then the parallel, or we can say resistance in parallel, you will get, you have the LCM to be 20. Okay, so here you have to multiply by 10 plus 5 plus 4, so this becomes 19 upon 20. So resistance of this parallel combination, RP if I write, then it becomes 20 upon 19 ohm. So this is a very easy calculation. Okay, then the next part is also there. Okay, if the combination is connected to a battery of 20 volt and negligible internal resistance, determine the current through each resistor and the total current drawn from the battery. Now the resistors are in parallel. Okay, so first of all we find the currents through each and every resistor. Say for example we have first resistor which is of 2 ohm. Okay, so this kind of connection you can understand. This is of 2 ohm, and this is of 4 ohm, and this resistor is of 5 ohm, and they are connected 2 ohm, 4 ohm, and 5 ohm. They are connected to a battery of 20 volt. So this is very easy to understand now. Now voltage across each and every resistor is same. Voltage across 2 ohm is 20, voltage across 4 ohm is also 20, and voltage across 5 ohm is also 20 volt. Now current I1, say flowing through 2 volt battery, then voltage upon first resistor, that is 2 ohm, so 20 upon 2, so this becomes 10 ampere. Similarly, I2 can be found easily now, 20 upon second resistance 4, so it becomes 5 ampere, and third current can be found, it is 20 divided by 5, so this becomes 4 ampere. So total current will be 19 ampere. This is the current through each and every resistor individually. If you add, because I1 plus I2 plus I3, all these are added, then you will get the total current. In total current I will be addition of I1 plus I2 plus I3. Okay, and that will be equal to how much? 19 ampere. Okay, so it's very easy to understand. Now numerical number 5. At room temperature, that is 27 degrees Celsius, the resistance of heating element is 100 ohm. Okay, so at room temperature, that is at initial temperature, say the value is how much? 100 ohm. So initially we have, say, value at initial temperature. Value at initial temperature, say T1. T1 is 27 degrees Celsius. That resistance R1 is equal to 100 ohm. Okay. Now you are heating it, and the value of resistance R2 is now becoming 117 ohm. Then what is the final temperature? The coefficient of temperature alpha is also given. The value of alpha is 1.7 into 10 raised to -4 degrees Celsius inverse. So these are the things that you note down, and you can calculate it easily. Okay, very easy to calculate. We just have to write the formula. R2 is equal to R1 1 plus alpha T2 minus T1. Now just you have to place the value. 117 is equal to 100. 1 plus alpha is 1.7 into 10 to the power minus 4. T2 we want to calculate minus initial temperature 27. Okay. This temperature is kept in Celsius only because temperature coefficient is in Celsius inverse. Now easily you can simplify this 100 can be taken in the denominator, so 1.17 is equal to 1 plus 1.7 into 10 to the power minus 4 T2 minus 27. Okay, so this 1 goes on the other sides and it becomes 0.17 is equal to 1.7 into 10 raised to minus 4 T2 minus 27. Now 0.17 divided by this value. Okay, so what will happen? 0.17 divided by 1.7 into 10 to the power minus 4 is equal to T2 minus 27. And if you simplify this whole thing, then this will give you 1000. So T2 minus 27 is equal to 1000. So T2 will be equal to 1027 degrees Celsius. Okay, thank you.